the questions. What you're looking at is a beautiful picture since you can't be here. This is called the Packard building. Over here is the Hughes. In the background, you can see St. Aloysius Church. And right here, you see all this digging going on. We are so excited that there'll be an addition to our complex for engineering, and it will connect us to the sciences. I will say just a little bit more about that. But the most important thing is that somewhere along the side, you cannot see, there is a walkway that connects Packard to Herrick. And the students and the faculty can actually stand there and watch this thing develop from the ground up. It almost is like a living, learning laboratory for us, especially for the students who are in civil and mechanical engineering. Here's a better shot of our campus, and this is a different shot looking at beautiful Lake Arthur. And there's something called the Centennial Trail. For those of you who are joggers or runners like me, I do take a jog or run that can take you for miles in either direction and also bring you into what's called the downtown Spokane area. Again, this is a different shot of Packard, and here is Herrick. And here is that little sky bridge I spoke of that connects the two buildings where the engineering and computer science, also mathematics and physics are located. My office is right in this little corner, and I can see out over to the soccer fields. Right here is our Foley Library, so notice a quick connection to Foley Library. Over here is the Hughes Science Building, which a lot of our students do take chemistry in this building and biology. Over here we have the McCarthy Stadium, where our Bulldogs play basketball. This is the Myrtle Wilson Arts Center, Performance Center, and over here is the Junt Museum. So we are really well situated on our campus. The Hemmingson Student Center is over here, and this little place is known as the Herrick Quad Center here. So we're very well located in a very, very beautiful location on our campus. Our mission is to produce broadly educated and capable engineers and computer scientists ready to contribute innovative solutions for a better world. And we take strongly what our mission really means as it underscores our values. Our programs are civil engineering, computer science, electrical engineering, engineering management, and mechanical engineering, and all of our programs are ABET accredited. We have 735 total students in this particular academic year, of which 202 are new students. And we have over 100 faculty staff and what we call Design Advisory Board professionals serving our students. This is a shot of one of the civil engineering labs, and you can see the students are having some very hands-on experience with mechanics of materials. This is the building that an artist rendition of that space I pointed to that right now looks like a bunch of dirt. This is the building that will add over 82,000 square feet of space for which both science and engineering and computer science students will occupy. And the artist rendition shows that faculty office is located here, but the open viewness and a lot of maker spaces for the students to interact. And we believe that the challenges that we face in our society, whether it's nationally or internationally, will require in collaborative and integrated solutions for engineering and science students and professionals. Here is a better shot of what it looks like now. You can see the development of that building taking shape. And this would be the artist rendition of it in this picture here. And over here, what I'm trying to show is that if this is Packard and this is Herrick, here is our Foley Library. This will be where the integrated science and engineering building will occupy, and they will be creating another skywalk that connects this building to Hughes. So in the end, we will have a quadrangle of buildings that will be dedicated to the STEM activities on our campus. We're looking for the opening of our ISC building by September 2021. At our core, although we emphasize our engineering and computer science training, that is what you're here for, we do never forget that we are at a university that has other core values. As students of a Catholic, Jesuit, and humanistic university, we educate ourselves to become women and men for a more just and humane global community. As such, the programs that you will go through has 45 credits dedicated to liberal arts, philosophy, religious studies, with an emphasis on writing, global studies, and social justice. So although we are educating you to be engineers and computer scientists, we believe these additional emphasis area, which underscores, again, our values, is also the attributes that will differentiate you from just another engineering or computer science graduate. In our curriculum, we emphasize what's called a first-year seminar. It's actually a two-sequence course, and that means that all the engineering students are put in these two courses, and we are trying to get for the students an opportunity to get more engaged into what that particular engineering discipline is all about, and also allow you to switch if you say, oh, this is not the engineering discipline I really thought it was. But more importantly, in switching, you don't lose any time in your courses. In other words, all the courses count, and you don't have to take additional courses. So this we emphasize in this first year seminar both lecture and what we call studio, based upon projects. There's a discipline awareness, as I spoke of. There's an emphasis again on technical writing. There's an emphasis on communication. There's an emphasis on connecting the students to each other. And we also emphasize early analytical tools because engineering and computer sciences are quantitative majors. So we start with the first year seminar and studio, which is required, and we end when you're a senior, you have to take a year long, again, a 2-course senior design project. This is not coursework. These are teams of students that are led by faculty and most often an industrial person on a senior design project that introduces them much more to the professional requirements that they are embarking on. There are many opportunities for our students besides just taking coursework. We also have, this is a Center for Engineering Design and Entrepreneurship, who actually provides the projects for senior design. The students are also able to use what's called the Manufacturing Technology Center, and I'll show you a small video of what's in there. And there's the opportunity to also go and study abroad with the Gonzaga in Florence program, which usually occurs in the sophomore spring semester. And we have over 12 student professionals and chapter clubs that students can get some engagement about different projects and also do some community work. We also have a dedicated career fair for ourselves. And actually in the fall of 2019, before we were hit with the current challenges, over 70 potential employers showed up at our Henningsen Ballroom Center. And you can see that that's a sign that there is a need for this kind of, for the STEM workforce. And the university actually has dedicates that career just for engineering and computer science. So it's not for the entire campus. And they also do a survey to look at where our students are going, and I show here some of the top employers are Boeing. Yes, Boeing is still a top employer for us. And the top cities are Seattle, Spokane, San Francisco. And you can see the average salary and the success rate. And we expect this success rate to continue. Here is the small video I wanted to play for you that shows a little bit more about one of our laboratories. So I will stop there and thank you for spending the time with me and take some questions if you have any, or if they've not been responded to in the chat session. Don't forget to unmute yourself if you wanted to ask a question out loud.
We don't have any questions in the chat just yet, so please feel free to type those in or unmute yourself and ask those out loud. We're excited to answer your questions, and we have a current student here as well who can give some of her perspective also.
And just to get things started, I'll say a few things. First is that we pride ourselves as a faculty to help you graduate in 4 years. Not 5 years, not 6 years, 4 years. Most often, our students don't take summer classes in engineering or computer science. You may take a philosophy or religion course over the summertime, and usually that is online. Another thing we ask of our students is every student who comes to the School of Engineering and Applied Science must bring their own laptop. And in these days where, things are becoming remote and online, we were ahead of the curve when the challenges hit in the spring because our students all had their own laptops. Now, every laptop is not created equal. We know that. And so we do have on our website the specifications for the laptop. And we emphasize that you need a Windows platform. Why is that? Because the tools that we use that are required for our engineering and computer science courses don't work well on Mac machines. I should say, need restate that. That was misspoke. The software used in engineering requires the Windows platform. Computer science is different. A computer science student, Mac platform is also welcome because you will learn about Apple, Windows, Linux. You'll be doing all kinds of, fancy stuff because why? You're leading the way in developing these things, right? But do keep in mind, if you're going to be an engineer, we will require you to have a Windows platform, and their specification can be found on the website.
Carlene, looks like
yes.
There's a lot of questions coming in now. So.
Very good. Please go ahead and ask the question out loud, or Kinji and Maddie and Susel will be able to respond through the chat, or Joan.
Yeah. I'll go ahead and I have some questions lined up that were in the chat for you, Dr. Hu.
Yes.
The first one, just kind of going in ascending order, is if you could just give a quick example of what a lab would look like for a computer science, for the computer science program. And then we have some more questions around direct admission and a few other things, but we can start with that one there.
Right. So you can imagine that the computer lab will have a lot of workstations. You'll get the ability for the student to use a particular workstation that has maybe 2 or 3 operating platforms that the student then for that particular course would have to use that particular platform. Or the student can plug in their computer. Usually there's a docking station, a mouse, and an extra monitor. When you think about these things, that I have a laptop, it's only this big, right? But we want you to have a second monitor, so you basically would have a 2-monitor station, laptop, mouse, that kind of thing. Other things that we do is very specific for that computer lab. For example, if you're learning robotics, if you're learning cybersecurity, if you're learning operating management, so each computer lab can be outfitted differently. Yes, Claire?
I'm sorry, that was my question, but I meant like what kind of projects would you be working on, not what the actual lab looked like. I'm sorry, that was a little bit unclear, but I just wanted to know what like an example of an actual project would be.
And I'm gonna go ahead and step in really quick. Dr. Hu, would you mind sharing your screen? Really
Thank you. That would be good. Thank you for directing me.
Yes, absolutely.
I'm not the most computer savvy, especially when I'm not in my office. Students, everybody, I'm at home. Go ahead. Thank you. Is that better, Kenji?
Yes, thank you.
Fantastic. So let me try to go back to the question that was asked by Claire. Claire, it depends on the class. In robotics, for example, you may be trying to understand how to program the robot to do different things. In cybersecurity, you may be looking at some kind of, cyber range mission. And I think it's about penetrating this, or virtual machine that, I'm a chemical engineer, Claire, so I'm going to way over the edge if I keep saying something out of place, right? So, or you may be looking at how to really manage an operating system. And then the other ones that are very popular are database projects. So you may be getting data from, picking up data from some kind of system, and then managing or understanding how to use that data in a particular application. If you could go on our website, to the computer science website, you will see the required courses. And just by the very name of the courses, you'll probably say that could be a project. Dr. Sean Bowers, who is the department chair, will be happy to get your questions and respond to them, as well as any professor that's listed there. They all do really different things. I think we have one that we just hired, and he does games and lots of graphics. And he also has a video up there where I think he's doing some kind of a ball tossing event and tracking that particular game. I didn't answer your question, but I'm not a computer scientist. I'm doing the best I can. Thank you.
That was a good answer. Thank you.
Thank you, Claire. That was kind of you. Who else?
So still a lot of questions in the chat. So we're trying to type some answers. We'll also be asking some out loud to you, Dr. Hu. Let's see here. Let me get back up to where we were. So quick question, is direct admission into engineering? It is for first year students. We are a direct admission. You'll need to mark engineering on your application, in the common application when you're applying to Gonzaga. Dr. Hu mentioned the ability to change between engineering disciplines. You can absolutely do that once you're on campus. You can also mark undecided engineering if you're not sure what discipline you want to go into. We have to apply into the engineering school, with the exception of our computer science major. That is not a direct admission program there. Can you talk a little bit about class size? So 11 to 1 student faculty across campus, right? But within the STEM courses, within the engineering program itself, what's the largest class that a student could expect? And what's the student to faculty ratio within the School of Engineering?
Thank you for that. It varies. In the computer science, for example, in the lower level classes, you have students who are taking computer science classes that are not in the School of Engineering and Applied Science, right? You might have nursing students taking it and business students taking it. But we do limit the class size we cap the capacity at 28. In some of the electrical engineering classes at the junior and senior level, we cap the class sizes at 20, 22. In mechanical engineering, which has the largest number of students, again, in the lower level classes, I believe that in the lecture sections, we cap at 25, but in the lab sections, we have to be very careful. Safety is important, right? And the instructor doesn't have eyes in the back of their head. And we really want everybody to be safe and use goggles and all the necessary training. So the cap on those lab classes is highly dependent upon the number of workbenches we can have in there. I think in the manufacturing class, we cap it at 15. We are very careful, very, very careful, that you learn in an environment for which you see the instructor. We are not giving your learning away to a graduate student or to another student. You are learning directly from the instructor, and the instructors pride themselves, our faculty pride themselves in being able to work with you. But what you may not know is when you're in your second year, when you are in your major, you're assigned to a faculty to advise you. So while Joan advises the first year students, because they do switch around, once you hit your sophomore year, you're assigned to a particular faculty advisor, and you stay with that faculty advisor until you graduate. Now let's go back to that direct admit pathways for a moment and ask Joan, could you give us your impression of the direct admit pathways and then compare it to the pre-engineering pathway for us?
Yeah, sure. So we do have direct admission. And so if you indicate on your application that you want to do an engineering major, you will be evaluated for that. And, you know, we do have as Carlene mentioned, or our dean mentioned, we do keep, you know, track of how many students that we're having. We don't want to have too many in a classroom. So there is a finite number that will be admitted through the direct admit program, and we leave that to our colleagues in the Office of Admission. However, we do allow students to come in two different ways. The first way is if they're not selected for direct admission to engineering, they can come in as a pre-engineering, and as long as they meet certain grade point requirements, they would be fully admitted to the program. We also allow students who maybe didn't think they wanted to do engineering, and so they didn't put it on their application. They have an opportunity once they are at Gonzaga to get into an engineering major. So it's very similar in terms of grade point requirements, but we want to be open and welcoming and yet maintain our small class sizes. And so, but there are two different ways. So if you're not immediately accepted into the direct entry program, you can come in as a pre-engineer. And then if you're already at Gonzaga and doing some other major and change your mind, you can come in as an internal transfer to engineering.
I'd like to add that when you hear the term direct admit at other universities you may be thinking of, it's not the same thing that we do here. It isn't. In many of our competing schools, direct admissions does not imply that if a student is interested in mechanical engineering, after their first year, they're admitted to engineering, in mechanical engineering. Gonzaga is different. If you come in as a direct admit and you want to be a mechanical engineer, and you say, that's still what I want to do after your first year, and you're making the grades, you're putting directly into mechanical engineering. Okay? So it's not a holding place where you say, oh, I want mechanical engineering and I'm going to be ending up in something I don't want to have. That is not so. You will, if you make the grade, you will be in mechanical engineering. So no student is really turned away. The important point to underscore here is we want you to be successful. We want every course that you take to count towards your degree so you finish in 4 years. So we pride ourselves on small classes, advising our students ourselves, and trying to get you to finish in 4 years. Those of you who choose to go off to international study, we have set it up so every course you take there also counts towards your degree program. So no time is wasted in what you do once you are a student in the School of Engineering and Applied Science at Gonzaga.
Thank you, Dr. Hu. We are getting quite a few questions in the chat around internship and co-op type programs, and along with that, just what the progression looks like through the program. I know you talked how you are in the engineering program when you start on campus. But could you talk a little bit more about what research and internships and any, I know we don't have co-op programs, but our version of internships, what that looks like on our campus as you progress throughout the engineering program?
Yes, Kenji is right. We do not have the co-op program. I have experience at other institutions that do have co-op programs. What the co-op program does is it occurs in the actual semesters, right? And so your time away from your coursework. So those schools who have the co-op program, actually your time to degree increases because you can't physically be taking classes, and the concept of co-op is you're working for an industry or business. We emphasize the internship. The internship usually happens in the summertime. And it turns out we have more internship opportunities than our students actually take on. And why is that? Because most of our students don't necessarily want to travel to the places or spend the summer in the places where the internships are located. We have two means of setting up our students for internships. One is through the faculty, but the other is through our Career Center. And we do have a dedicated person in the Career Center, Karen, what's her name? Karen Franks-Harding, who spends 2 days a week in the School of Engineering and Applied Sciences, setting up appointments with students and trying to do the matching of the internships. So remember the career fair I showed? Over 70 employers showed up. Most of them are looking for students to also do internships. In the Spokane community, we also have internships available. Again, it's really up to the student to decide if they want to spend their summers doing it. So I don't see a problem with the internships. And internships do not add time to your degree. Research, we are excited about that. Most of our faculty want to work with students in their labs doing research, and we actually have funding to sponsor students to do research. In other words, paid research experience. And you can do this during the academic semester. We do it very carefully though. We don't want you working so hard at research that you forget about your courses. Remember what your purpose is here for is to take your courses and graduate, but also get the undergraduate research experience. So for those of you who say, I really want to go on to graduate school, or I really want to learn something more about tribology or something more about automotive. We do have those research, paid research experiences. Our faculty do want to work with you during the semester. We also have some over the summer as well. They're very competitive, but they are available to you if you're interested. We also believe that hands-on experience, working directly with the faculty, helps you to better understand the profession you're entering. And our faculty are passionate about wanting to have you work with them and to do it safely as well. And to do it safely, always safety. Does that help, Kenji?
Absolutely. Thank you so much. This next set of questions is actually more, I think, in Joan's wheelhouse. And it's really, we've got a couple of questions in the chat around double majoring with an engineering program and what that can look like. And then along with that, and this may be more for both of you, but students who are thinking about a pre-health program or a graduate program or career that may not be in engineering, but they're interested in engineering, what would you recommend for that as well? So I guess double majoring in engineering and engineering, or choosing something else if your career path may not be in the School of Engineering.
Go for it, Joan.
You know, it's quite a common dilemma for high achieving students that are interested in engineering. They tend to also be interested in the health sciences or other science STEM fields. So I would say just in general, if you came to Gonzaga and started in engineering, that first semester, most students are taking calculus and chemistry. And so if they decide at that point that engineering is not for them, it's quite easy to shift over to a chemistry or a biochem or biology major, maybe human physiology, and the courses will still apply. It's not like you've wasted a significant amount of time or credit or money on something that you're no longer interested in. Conversely, if you start off in like a biochem or a chem major or something like that, you can do an internal transfer to engineering, but you would miss out on that first semester in the engineering seminar. So that would be delayed until the next fall. So in my own opinion, I think it's probably, if you're interested in both pretty equally, might be better to just start with engineering and we can talk about it. And if you decide that's not right for you, get switched over your second semester or after your first year. What do you think, Carlene? Do you agree with that?
Yes, I want to tell you that better than 20% of our undergraduates are doing double majors, minors, concentrations, a lot of music. Many in engineering majors do a computer science. Let's take a student who's getting a computer engineering bachelor's degree. They're also minoring in computer science, some minor in biology, human physiology. I think that engineering computer science students are just what they call the A brain, right? The A student who's going to just always do well. And large number of you are also in our honors program. Now, if you say, yes, an engineering a degree is good, but I want to go on to something else, maybe to medical school, the one I like is law school, or to an MBA, look closely at our engineering management program. The engineering management program comes with a minor in business. With just one additional year at Gonzaga, you pick up your MBA. The students who are in the engineering management program are highly recruited by our School of Business and Administration. A good number of our students also go on to medical school. Recently, remember CJ, Joan? CJ, mechanical engineering student, he worked and still finished in 4 years, and he's in medical school. So I think that there are many opportunities to do different things with an engineering or computer science background. And my reason for that is because our education of you makes you very quantitative. Numbers mean something to you. And in this day and age of data analytics, lots of knowledge-based systems around, lots of things like machine learning, artificial intelligence, lots of concepts about how we understand constraints and volumes, standards and codes. That's how we educate you. You become a very, very attractive graduate once you leave Gonzaga. Additionally, we have educated you how to communicate, how to write, and how to value ethics and standards, and to appreciate things like social justice. That education doesn't come all the time in the typical schools of engineering and applied science. So you are equipped to make a choice. And the faculty, when they advise you, wants to know, they're always asking, after you graduate, what is your first step into the career? We don't educate you just for your first opportunity. We want to educate you for a career over your lifetime. We care about you. You will be our graduate when you finish. So we care that we educate you and give you choices. Where do we go from here, Kenji?
We actually are mostly caught up in the chat. And I think just because we have Madeline here, I think it'd be great if, Madeline, if you don't mind, just talking about maybe a favorite course you've taken or one of your favorite experiences you've had throughout your time in the engineering program.
Yeah, so I mean, I'm only a sophomore this year, but they did talk about like engineering seminar, and I definitely think that like it's there for a reason. It is a really great course, great teachers. It's really nice because I see like a lot of questions in the chat. They're like, I want to go into engineering, but I don't know what I want to do. And you do labs every like sorry. It's about a lab that you work on for about a month in each field. So you do engineering management, mechanical, computer, things like that. And you also get lectures from the professors in that certain area. So you get to really work intimately like in an intro to each field. So I mean, I did end up sticking with mechanical. I declared mechanical when I first came here, but it was nice to be like, now I'm not questioning my choice in my field. I'm definitely sure that that's the path that I want to go on. I guess other experiences, like one reason that I decided on Gonzaga is actually on a course that I haven't even taken yet. I saw another thing in the chat kind of like about environmental. That's something I'm super interested in, and I know that there's a course as an upperclassman that's about like renewable energy and things like that. So there's a lot of really great opportunities in this program, and yeah, all the professors are awesome. I think some of my favorite professors so far are definitely like actually engineering professors, because you do take some core classes, but my favorite have been in the engineering program. So
That's great, Madeline. I need you to continue to do that. Thank you for that.
Thank you. Madeline, thank you. Let's see, I don't think we actually have any other new questions in the chat. Just a couple of things that I've heard throughout that I want to touch on quickly. There was a lot of questions that Joan gave you some great info around if you can double major. And I think one thing to keep in mind is you can always add more to your degree. When we say it might not work out, we're talking about a 4-year or a 5-year graduation path, right? So if you want to graduate in 4 years and have a mechanical engineering major, a music major, and a concentration in leadership, that's going to be really hard to do in 4 years. If you're not so concerned about 4 years, you can add more things to your time. But we are always looking at or thinking in a 4-year mindset, so we can get you into your profession as soon as we possibly can. That's our mindset there. So always possible. Just think about that 4-year constraint. That's always on our mind. And then we've got a couple of questions throughout as well about study abroad. I am a huge proponent of study abroad. That's one of the reasons why I chose Gonzaga, actually. But I was a history major, so I went to Japan, not to Florence or a few other places. So engineering students have some fewer options, but they're really, really cool options. And correct me if I'm wrong, but that would be Florence, Italy, Glasgow, Scotland, or Auckland, New Zealand are the 3 most common options for our engineering students, typically Auckland or Florence, Italy. And engineering students, you'll go in the spring of your sophomore year. Is that right?
That's right.
Awesome.
That's true. There's also a very popular one for electrical and computer engineers is Madrid, Spain. But Auckland is a popular one for computer scientists. Mechanical engineers and civil engineers really enjoy going to Gonzaga in Florence. No, it's not, you are going to be taking things in your major. So it's not just a time to go and let's say take philosophy or history or religion. we truly set it up and work very hard that when you go there, you are still studying your engineering subject matter. So it's, but I have to confess that every student that I've spoken to, especially seniors, and I asked, what was one of the most memorable things in your time with us? They have said, the opportunity to study abroad. The other one is the opportunity to research with the faculty. And the third one is the opportunity to be a member of one of our student clubs or societies. That's the way you grow and mature and develop lots of good colleagues and friends along the way. And that's what we hope you'll do. Kenji's right. If you do want to do double major, I just met a student who is majoring in, she's a mechanical engineering student who's minoring in physics, and she also wants to then major in mathematics. Wow, double major with a minor. She's not going to finish in 4 years, but she made up her mind. Now, here's the good thing. The average time for an engineering or computer science student to finish nationally is not 4, it's 6, right? 6 years. But that accounts for places where co-ops are happening, required co-ops, not optional co-ops. So we want you to think about 4 years, but if you want to stay longer and take advantage of everything we have to offer, oh, for heaven's sakes, as long as your parents are willing to allow you to do that, please do.
Thank you. And I was actually just about to call last question at 12:10. We'll end this session. But before I could ask for that, we had another question come in. So if you could just talk a little bit more about the computer engineering program. That was the final question that came in.
I think that's civil, Kenji. I think the person might have meant civil engineering, but I could be mistaken. So whoever asked that question, could you clarify?
Yes, they just did civil.
Civil, my apologies.
About civil engineering, from one perspective. So it's the civil engineering, they take their foundational classes in structures and materials, structures, materials, and usually foundations of steel. So that's the typical civil. But what goes beyond that is there could be a tract in environmental. And the focus environmental could be broad. It could be environmental from soil perspective. It could be environmental from a water perspective. And now we actually have a thrust from almost a biochemistry perspective, more microbial understanding of, for example, how we clean up stormwater. Then there's also transportation. We have a faculty that's very interested in understanding how to develop better transportation highways in urban cities that accommodates not just the usual automobile, but now we're seeing a lot of bicycles, right? Because there is an emphasis on minimizing the amount of pollutants in the atmosphere. So that's another area. A fourth area that they're interested in is more of the construction side of things. So the requirement by the accreditation for civil is to give the foundational courses. And by the way, physics is minimized in civil engineering, while things like geology, hydrology, and environmental and climate courses are more emphasized in civil engineering. So it is required by their accreditation that they give the foundation, but they also must allow the student a plethora of electives. So they can't, so for example, in mechanical engineering, I think it's 3 to 4 electives. In civil engineering, there are more electives. And in computer science, for example, you have to take, there are 14 electives that you take rather than just taking courses. The student actually puts together the curriculum to make up the number of credits to graduate. Is that a reasonable request to the question that was asked about civil? It goes from a structural perspective. It studies steel, different kinds of structures, including cement. One of our faculty is interested in what's called cross timber lamination, which is a combination of laminated structures, but reinforced with both steel and timber. But there's also the transportation, there's also water and microbiology engagement of that.
Thank you, Dr. Hu. Just for the sake of time, I'm going to just give please feel free to just kind of close. We have 2 more minutes left before I need to end the meeting. I'm going to put in the chat right now the Zoom link for our student panel, which is happening next at 12:20 Pacific time. I know you're not all on the West Coast, but in about 12 minutes is when that student panel will start. I highly recommend joining that. That's a great chance just to learn more about the student experience. But I'll stop there, and Dr. Hu or Joan, if you want to kind of give a bookend for us or a closing, that would be great.
Fantastic. Thank you. And yes, we need to keep you on time. I first want to say thank you again for joining me, wherever you are, what time zone you're in. I so appreciate your interest in our School of Engineering and Applied Science. When you start in fall of 2021, you'll be the first set of students in our new building. And we're so excited, and we want you to see you all there. We're here to support you any way we can, and we will be happy to answer any follow-up questions. I want to thank you, Kenji, and Zuzelle, and Madeline, and of course, Joan, for spending the time with us too. And for all the leadership that admissions counseling is providing. Thank you.
Thank you all again for joining us, and thank you, Dr. Hu and Joan, for giving your time on a Saturday. And thank you, everybody, for giving your time on a Saturday to come learn about Gonzaga and the engineering program. I'm going to go ahead and close this meeting in about 30 seconds, so I'll let you make your way out as we end here. And I look forward to seeing you all in the student panel. We then have financial aid information and then some interview or one-on-one meetings. So enjoy the rest of your day. Please reach out if you have more questions. Thank you for checking out Gonzaga and the engineering programs.
Thank you.
Take care now. Have a great day.